All right, I wanted to provide a little bit of homework help for you on this part 2 of simplifying radicals, where we are simplifying cube roots, and then the other sheet that's attached, we'll be doing some adding and subtracting of radicals. So let's just go ahead. I've chosen a few problems from each of the sheets. So let me just go ahead and in case you're not all the way familiar with the numbers that do have perfect cube roots. So 2 cubed is 8. That would be cube root of 8, of course, is 2. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. And I don't think we'll need to go any higher than that, but if we went 7 cubed, that's 343. So again, I'll just put the cube roots in parentheses. I just took each one of these numbers starting at 2, basically, and raised them to the third power. Or going the other way, these are the numbers that when multiplied times themselves 3 times, give you the number underneath the cube root radical. All right, so the process, again, is just like we did when we were working on square root simplification. It's just that now we're trying to find, in this case, the number 216 in our list, and I see it, okay? So the cube root of 216 is 6. That means 216 is what we call a perfect cube root number. All right, so I'm going to set up my factoring as the perfect cube root number 216, and then I'm going to multiply that over here. You could think by 1, but cube root of 1 is just 1. So we've got 216 taken care of. Now we need to take care of the variable n to the 8th power. So the way we do variables is you want to know, check and see if the root divides evenly into the exponent. And obviously 3 does not divide into 8 evenly. So what we're going to do to factor out n to the 8th is make it n to the 6th, which 3 does divide into evenly. And then the factoring, remember your rule of exponents, when you're multiplying the bases that are the same, you leave the base and you add the exponents together. So n to the 6th times n to the 2nd makes n to the 8th. All right, so everything in this left radical is what we would call a perfect cube root number or variable. And so we can fully simplify this left radical. The cube root of 216 is 6. The cube root of n to the 6th, just think n to the 6th divided by 3 power, that's n to the 2nd. And then the radical over here on the right is not able to be simplified, and so this ends up being our final answer. 6n squared times the cube root of n squared. All right, number 12, we have this negative 3 that will be multiplied by any number that comes out of this radical as a regular number. Okay, so I'm going to just factor this as negative 3. I'm looking for negative 135 in the list. Don't see 135 in the list. So my next best thing to try to simplify this is to find a number in the list that divides evenly into negative 135. And with your calculator, it shouldn't take you too much time. I'm not going to give you a long list of perfect cube numbers. This will probably be the extent of it for what we do in this class. So with your calculator, if you do negative 135 divided by 27, or negative 27, you get 5. So the number I'm going to put in the perfect cube root radical is negative 27. And then to make it equal over here in factoring, I'm going to have to multiply times 5. So the cube root of negative 27 times the cube root of 5 equals the cube root of negative 135. So we got that taken care of. Now let's do the variable p to the 5th. To make that a perfect cube root variable, I'm going to raise it to the 3rd. 3 does divide into 3 evenly, which means that over here I'm going to make this to become p to the 2nd. 3 plus 2 makes 5. We add exponents when we're multiplying like bases. Okay, so I'm going to bring the -3 down, that original -3, and now I'm going to simplify this radical. The cube root of -27 is -3, and the cube root of p to the third is p to the 3 divided by 3 power. And all of this is going to be multiplied by the cube root of 5p squared. So to finalize my answer, I'm getting kind of far down into the next problem, but these two numbers, these coefficients, -3 and -3, now that -3 is no longer under a radical, I can actually multiply these together and make 9. So 9p is going to be multiplied times the cube root of 5p squared. And that's my answer for number 12. So number 13, let's take a look. We have 4 will be just brought down, and then let's see if we can simplify the cube root of 108. Well, 108 isn't in my list, so let's see with our calculator if we can find a number in the list that divides into 108 evenly. And it turns out that it's the same number that we had up here, except instead of -27, it's going to be +27. 27 times 4 is equal to 108. For n to the second, 3 does not go into 2 evenly. 2 is smaller than 3, so I can't do anything to break this up into 2 factors where 3 will divide into the exponent evenly. So I'm going to have to put n to the second in this right side radical that contains all of the non-perfect cubes. So bring down the 4, the cube root of 27 is 3, so I'm just showing 4 times 3, it's no longer radical, and then I'll just bring down this other radical that has to stay radical, it cannot be simplified. And then to finish off our answer, I'm going to do 4 times 3, which is 12, and that's going to be multiplied times the cube root of 4n squared. And that is my answer for number 13. All right, so for number 28, again, we got a number being multiplied. So let's see what we can do to simplify the cube root of 162. So I'll just go back and refer to our list. 162 isn't in the list. So best case scenario is to find a number that divides evenly into 162. And there's that number again, it's 27, because 27 times 6 equals 162. So the cube root of 27 times the cube root of 6 equals the cube root of 162. The exponent 2 is smaller than 3. There's nothing I can do to simplify that, so I'm going to put x squared over here in the right group that contains all the leftovers. Y to the 6th, however, is already a perfect cube root variable because 3 goes into 6 evenly. And so now I'll simplify this left radical fully. Notice I'm no longer using radicals to represent this because everything that comes out of this will be regular numbers and variables. I'm just putting them in parentheses so I can multiply by -4. So the cube root of 27 is 3. The cube root of y to the 6th, that's y to the 6th divided by 3 power, that's y to the 2nd. Still will be multiplied times the cube root of 6x squared. And I'll just put our final answer over here. -4 times 3 is -12y squared. And then that's going to be multiplied by the cube root of 6x squared. That's your answer for number 28. And then we dealt with this earlier. We had, I thought we had 128 already, but I guess we didn't. So let's see, 128 is not in our list. But I noticed that 64 is, and 64 times 2 is 128. So this time I'm going to use the perfect cube root number 64. And that will be multiplied by the non-perfect cube root number 2. Again, u to the second, this exponent is too small. I can't simplify it, so I'm putting u to the second over in the leftover radical. I can separate v to the fifth. I can make it v to the third, which 3 can divide obviously into 3, which means over here I'm going to have to put v to the second. So just check, make sure that these two radicals multiplied together equal the problem radical. And this left radical will become, the cube root of 64 is 4, and the cube root of v to the third is v. And that will again be multiplied by the cube root of 2u squared v squared. And then to get our final answer, I'll come up here again. Negative 6 times 4 is negative 24v. And then that'll be multiplied by the cube root of 2u squared v squared. That's your answer for number 29. All right, we got one more on this sheet, and then we'll look at some adding and subtracting examples. So bring down the 7s, see what comes out of this that can multiply by 7. 48 isn't a perfect cube root number, but 8 is. And 8 divides evenly into 48, so let's represent the cube root of 48 as the cube root of 8 times the cube root of 6. 3 does not divide into 1 evenly. The exponent is too small, so x to the first will go over in this leftover radical group. I can break up y to the 8th into a variable that can be divisible by 3, its exponent, which means I'll put the leftovers over here on the right. And now simplify the left radical and see what comes out that can multiply by 7. The cube root of 8 is 2, and the cube root of y to the 6th is y to the 2nd. 6 divided by 3 power. All right, and then to finish our answer off, I'm just going to multiply these together. That's 14y squared times the cube root of 6xy squared. And that is your answer for number 30. All right, let's do some addition and subtraction. And these are all square roots. Now remember, in order to add or subtract radicals, the roots have to match. So the index, in other words, has to be the same. And then the numbers under the radical also has to match. That's called a radicand. So before we make the determination that, hey, we can't do this because the radicals are not the same, let's see if we can simplify. And I'm going to break up the square root of 20 as the square root of 4 times the square root of 5. So all I'm doing is factoring using radicals. Instead of root 20, I'm showing it as root 4 times root 5. The square root of 4 is 2, so I'll just do another step. Now I can multiply these two numbers that are not radical. Negative 3 times 2 is negative 6 times the square root of 5 minus, you can think of this as 1 times the square root of 5. Well, now they have the same root, they're both square roots, and they have the same radicand. So I just operate with the numbers in front of the radicals. Negative 6 minus 1 is negative 7, and you just leave the radical as it is in the problem. So there's your answer for number 15. Number 18, I'm going to write the square root of 18 as the square root of 9 times the square root of 2, because I can simplify the square root of 9. With the square root of 8, I'm going to represent that as the square root of 4 times the square root of 2, because I can simplify the square root of 4. And then for the square root of 24, I'm going to do the square root of 4 times the square root of 6. All right, so negative 3 times 3, square root of 9, times the square root of 2. 3 times 2, that was the square root of 4, times the square root of 2. And then this is going to be 2 times the square root of 6. The square root of 4 becomes 2. Now I can multiply negative 3 times 3, that's negative 9 square root of 2. 3 times 2 is 6 square root of 2, minus 2 square root of 6. So two of these can actually be combined into one radical, but this other square root of 6 cannot be. So the best I can do, my final answer is going to be negative 9 plus 6, which is negative 3 square root of 2. And then I'm just going to show that I'm going to have 2 square root of 6 subtracted from that. But I can't actually combine those into one term because they're unlike radicals. There's your answer for number 18. All right, and then our last two, more of the same, it's just 4 radicals involved, so some practice in simplifying radicals, square roots. All right, so there's the square root of 20 in radical factors. Again, I'll tell you what we could do to make this process a little simpler is just go ahead and combine all the square root of 20s. These 3 can be put together. So 2 minus 1 is 1, plus 3 is 4. So I can put all those together, and then we just have 2 radicals to simplify. So 4 times the square root of 4 times the square root of 5. That's the square root of 20. And then this is going to be minus 2 times the square root of 9 times the square root of 5. That makes 45. All right, so 4 times the square root of 4 is 2 times the square root of 5. 2 times the square root of 9 is 3 times the square root of 5. And now let's get our final answer. 8 square root of 5 minus 6. 2 times 3 is 6 square root of 5. And these can be actually combined because they're like radicals, so my final answer is going to be 2 square root of 5. That's number 26. And one more. We could go ahead and put these 2 square root of 45s together since they're the same. I'll just bring down the negative square root of 27. So negative 3 plus 2 is negative 1 square root of 45. And if you want to put a negative 1 there, it's fine. It's kind of like the same thing of writing 1x instead of just x. We don't need to show a factor of 1 being multiplied. And then I'll bring down the square root of 20. All right, so simplify the square root of 27. That's the square root of 9 times the square root of 3. The square root of 45 is the square root of 9 times the square root of 5. And the square root of 20 is the square root of 4 times the square root of 5. Okay, so the square root of 9 is 3, so this is, if you think of this as multiplying by negative 1, this would be negative 3 times the square root of 3, minus the square root of 9 is 3 times the square root of 5, minus 2 times the square root of 5. And now these 2 root 5s can be joined together as 1, but I can't do that obviously with root 3, so final answer is going to be negative 3 root 3 minus, and we put those together, negative 3 minus 2 is negative 5 times the square root of 5. And that is your answer for number 28. So I hope I've done enough of a sampling to help you out with the other problems, but if you do have any questions while you're working on these, feel free to contact me. Otherwise, I will see you next time.